Good morning. I'm Shatha Aziz. I work at Western University, as someone has introduced me. I teach mathematics and statistics subjects. Today, I'm going to just explain some of the stuff that I dealt with during the pandemic. So all of us learned some new educational, like online tools. All of us would like to overcome the challenges that we faced during the pandemic, at least some of them, like students' disengagement, academic misconduct, stuff like that, I hope that you all experienced like us. So what I thought, I'll just share with you what I've used, some of the stuff that I've used. I'm a fan of Numbas, as you can see when I can explain the stuff. So I'll start with just showing you why I use these ones, why I chose GeoGebra and Numbas first. Numbas, I don't have to convince you, they've done the work for me already. GeoGebra, so I'll start with saying I teach some of the lowest mathematical units, like analysis of change. This is really one of the main reasons why I looked at visual stuff. So I will show you some of the slides that I teach in analysis of change. Then you will see why I really use GeoGebra. So I'll start with why visualization. First, it's really an easy way to communicate. It's one of the easiest ways to communicate, actually. All of us, if I don't want to say anything and I don't want to tell you go right, just this way. And you need to take my right, not your right. Okay, so it's the most effective way that I can think of when it comes to the lowest units. So you want to talk to them without stressing them. You want to tell them that you are doing okay. This is what's happening. That's how I can help you. Let me know if this is working. So I started with saying, okay, is this supported? Is it only my opinion? Visualization is good. But okay, let's research it. I found many research. That's one of them, and I've written some other research in references, but I haven't really explained them here. So this is one of the studies that support the visualization. It's an experimental study, so it's not just talking. They run an experimental study, statistical experimental study, and they had two groups, experimental and control group, as you know, statistics. And the results were students' ability can be improved using instructions they've given it using visualization, so visual aids. And also they say that the learning outcomes were better. And that's what I like, differences between genders can be eliminated. You know, when we look at geographical data like maps and instructions, females, not all of them, but females usually less, their abilities are less in following instructions when it comes to maps and stuff like that. This is really running on that, or this has been experimented on something like that. And it says that gender inequality can be eliminated, which is great. So that's one less problem for us. Okay, so now we all know that teaching is an interactive process. And not only do we know that it's been approved, it's an interactive process between educators and learners, right? And we know by now, and you already know that, but I've just proved it for you using the study, that visualization improves interaction. So why I don't combine these? I can combine them, but which educational technology can combine both? Many, actually. But why I use GeoGebra? I will tell you later. So many graphing calculators can be used, many visualization aids can be used, but remember always that I'm a fan of numbers. So now, GeoGebra is the one that I've used. Is this only that because I like it? No, one of the reasons, there are many studies that support the use of GeoGebra specifically in teaching and learning. And remember, I'm talking about teaching one of the lowest mathematical units. So something like fractions, limits, continuity, stuff like that. And I'll show you some of the slides. So when you get something that is visual and it's being tested on stuff like that, so in high school stuff or stuff in school, you better use it, right? So this is a study which has been conducted on school students. I don't remember, to be honest, if it's high school, if they were high school students or not. But they claimed in this study that parabola teaching was one of the hardest topics according to student feedback, and they used GeoGebra to overcome the problem. So they used Visual A. They again run an experimental study, control group and experimental group, and they found that both groups were not at the same learning level. In fact, the experimental group done better. And they specifically stated that visualization helped students learn or enhanced student learning. Okay, so now, since I convinced you, hopefully, I'm gonna now say, okay, I used GeoGebra, but it could have used any graphic calculator. Like, it doesn't make any difference to the first step that I'm talking about. I just use it in tutorials, explaining some of the stuff that I'm explaining in tutorials. Get a great feedback, really positive feedback. I used it in lectures, and that's after I started using Numbas. I always keep this in mind, yes, because it's during the pandemic. So I'm talking about analysis of change, one of the lowest units that I teach, or one of the lowest units of mathematical units that you can see. All right, so some of the topics that we teach, these are really screenshots from the lecture notes. We use visualization in these lecture notes. We have graphs, we have sketches. So we explain limits at infinity and other limits like this one, the one which is the continuity limit, figuring out if it's continuous or not. We teach them the asymptotes, how to find an asymptote, and I'm saying we teach them algebraically and using graphs, and that's in the lecture notes. So it's not something that I come up with, it's already in the lecture notes. Okay, and other stuff that we teach them as well, how to graph different functions, but specifically some trig functions like sine and cosine functions and other functions. And we teach them in general what happens if you multiply a function by a number, if you add, subtract, like Numbas function, if you multiply the independent variable by a number, what happens? And we teach them both ways again. If you have the function, how to graph it. If you have the graph, how to find which function, but only for sine and cosine in the other way. So the other direction, only for sine and cosine functions, right? So we also teach them differentiation, but keep in mind, this is the second last lecture. The hardest, one of the hardest, the one which is harder than this one is just application of differentiation. Most of them don't answer any question related to this because it relates to optimization. So maximum volume, minimum surface area, stuff like that. Okay, so by looking at this graph, just keep in mind that in lecture notes, the same graph is used again and again. Move the point around the on the graph, on the curve itself, and show them the rate of change, what's happening. How do you reach the conclusion that the differentiation definition, derivative definition is just limits of rate of change? So all of that done using slides. So okay, I've already introduced GeoGebra tutorials. This is the second last lecture, one of the hardest. Why I don't use it in lecture, explain these many slides and make it just interactive instead of moving the slide, showing them the new point, why I don't use GeoGebra. Just wait for it to load. So that's what I show them, of course. So it doesn't show the other one. If I click the link, okay, I'm gonna just minimize this in this case. I thought if I click the
maybe stop the share and then
yeah,
maybe I'd share the whole
Yeah, maybe
thing.
you
Yeah.
share it in the window rather than
just close the
Oh,
presentation. I thought it will just take it from the presentation to the new one. I guess it doesn't. So that's what I used. It's actually the same graph with just extra lines to show them what's happening. So if I use the slider, which you can find in any other, in many graphic calculators, but I'm biased here. So you just show them what's happening when you move the point on the graph, what's happening to the rate of change, and I'm explaining that while I'm showing them. Then what happens if the point comes as close as possible? What's this line, and how do I define it as why it's a limit? Because I already used GeoGebra to show them how to find the limit on a graph. So the point is moving towards the limiting point and stuff like that. So they have some knowledge, or they've seen GeoGebra before, and I can just, like, it's dynamic, as you know. So I can just show them this several times, and I get rid of many slides, right? So let's go back to this slide. Okay. So I'll go back to this one. Okay. So now, this is only using a graphic calculator, not really that much interesting when it comes to GeoGebra. Why GeoGebra? Why not any other graphic calculator, right? So now we know that when it comes to mathematics, many students learn by solving questions, right? Many students ask you, I want more, the good ones, the ones that they want to practice. I want more questions with solutions. I want to be able to solve the question, make mistakes, and look at my solution, compare it, and learn from it. Makes sense. I always tell them, look, make as many mistakes as you like. It's okay. It's the first step to learning. If you learn from your mistakes, you'll get better. Okay? But would you like to create 100 types of questions and upload each using Word or PDF or later, whatever you're using? You don't, right? You don't want, it's not practical. You won't do it. So here comes Numbas is handy now, right? I can use Numbas, and I create many versions of each question, as they explained to you already, using variables. Okay, so I used Numbas, created practice questions for them to help them like practice for tests and to learn any topic. And that's happened again for analysis of change, because that was the first semester that I used Numbas after the introduction of Numbas here in FYI Math, and after the help of John and Jim. They helped us all in mathematics, like in the mathematics group at Western Sydney University. Not all of us, some of us were already using Numbas, but we, the last ones who used it. Thank you, Don and Jim. So I used Numbas to create many of the practice questions, but I was thinking it's never enough for you. As an educator, you always want more. So I was thinking, okay, I've already used GeoGebra. And why I use it? Because I know in advance GeoGebra can be integrated with Numbas. I know nothing about creating the fancy graphs that Stephen can create using LaTeX. I know how to create like PDF files and stuff using LaTeX presentation, but I don't know how to create graphs. When it comes to GeoGebra, it's very easy to create graphs. It's interactive, it's dynamic. You can give Numbas, let Numbas create the variables, send it to GeoGebra, and you get a new graph. So that's easy for me, quick. I can learn it quickly, I can use it, and it's good enough for the purpose. So I thought, okay, let's use GeoGebra then. It adds an extra layer to Numbas, right? Because I have now an extra option, not only to visualize the questions, not only to help them practice questions. There's another thing. With online assessments, can you take a graph and plug it in an online calculator? Not yet. Not so far, right? It may happen one day, but not so far. So even if they want to use online calculators, if I give them the function as a graph, not as an algebraic expression, it's a win-win. Visualization, and they cannot plug it in an online calculator. I know Numbas is very powerful, true, and that's why I love it. It creates many versions of each question and it prevents colliding. But look at that, it's another thing, extra layer that prevents another gap that has been filled. So perfect. for me, worked well. It may not work for you the same as for me, but for me, for my students, it worked very, very, very well. Now, since 2021, I integrated GeoGebra with Numbas to create the more efficient practice questions, online assessment, stuff like that. Things that cannot be solved, at least some of them cannot be solved using online calculators, the graphic ones. So these are the types. This is how it looks like in views. I just thought you don't have to log into views. You just click on that. You practice. I provided them with different types of questions, like one for this topic, one for the other topic, with whatever relates to that assessment. Okay, and that's in each assessment I created stuff like that. Now, multi-version questions, algebraic questions, and multi-version questions using graphs. So graphs are in multi-versions. It's not only one version of graph. It's not only one function that you can use, but the same function that you can use, you can make it look different, which I will show you later. Until now, I haven't showed you anything. I will show you now. So I thought it would take me, but I will have now to minimize this. I'll just click the link and I will minimize the presentation. And now you can see it. That's one of the questions that I've created. I'm asking them to find the limit of a function, which is unknown for them, but they have the graph. Look at the graph. I will show you from Numbas how it looks like how it's changing. I can here try another question, but I'll show you from Numbas so that it's easier to look at. They can grab it, click, move. They can zoom in, zoom out. If I'm searching for limit x approaches -4, and I can't see here -4, zoom in, search for -4. Where does it intersect? It's too big, zoom out, -4, where does it, I cannot say this. I can guess it's probably -7, but let's check. So that's -4, as you can see it here, and it's intersect there, and that's -7. Okay, so now that's what I provided for them. That's one of the questions. I will show you another question here, and then we'll go to Numbas. So that's the whole practice test, or one of the types that I showed you in views. I'm going to run it now, and I'll show you one by one. So if I start the test, that's how it looks like for them. This one changes every time you run it. You can see that I have limit at infinity, limit at -infinity, limit at a number from the positive direction, right hand side, left hand side, stuff like that. Again, you can move it, you can zoom in, zoom out. Now, similar sketch, different one though. I'll show you quickly, different one. But now find the asymptotes. All right, so make sense? This is practice. That's not an exam. That's for practice. And in tests, I use similar stuff. So they get used to it, then they see it in tests. Now, two types of asymptotes, vertical and horizontal, and two of them. Same stuff, just to practice more. I told you that I created these type of questions in one practice test, another type in another practice test, and so on. Then same thing now with horizontal and vertical asymptotes. And here a little bit different question. What happens if there's nothing to the left or nothing to the right? And this function changes, looks like that, looks upside down, things that it can change. So flipped over, concave up, concave down, it goes to infinity to the right, goes to infinity to the left, and all of that is just by sending variables from Numbas. Okay, so that's just the same one, same GeoGebra template, but you just send different variables. Again, they can zoom in, zoom out, whatever they want. They have to fully explain why they think this is the answer. It's not only say the limit does not exist. So if I end the exam, which is a practice test, it's not an exam. And I go to each question. Some of them I don't provide a lot of feedback because it's one of the easiest ones that they know, they should learn. Some of them, when I force them to explain more, I provide more feedback. Depends on what is in the lecture notes, what's the easiest, what's the hardest, stuff like that. I'll just show you quickly all of them. So you can provide this 5 minutes, yeah, almost done. So now sine and cosine functions. I'll just go to the sine one. I just ask them which sine function is this, and you know that sine function you can just like drag it to the right or whatever, and it will become cosine. So that's why I have to tell them this is a sine function, not a cosine function. I want you to find the sine function. So here we just tell them, I'm not going to be able to explain all of that. I'll just show you the answer, which will, or the feedback, which will explain my point of view. Just telling them, look, that's how it looks like between 0 and 2 pi. If you're checking this and it's once, twice, that's twice between 2 pi. So you've multiplied this x by 2. You look at the intersection point with the y-axis, sine must intersect the 0, it's been shifted up by 1, so it's plus 1, right? So now quickly just looking at the slides, show you another way of overcoming the cheating. That's just a bonus thing. So okay, so now Numbas is powerful. We all know that there's still many gaps that we need to fill when it comes to online assessments. One of them is GeoGebra for questions like the ones that I've explained. Actually, I can see that even the graphs that we had in Mathematics for Engineers 1 Advanced, we could have made them interactive using GeoGebra. So using other stuff that you own as well, use graphs. So I just thought there are other stuff. I cannot cover it up when I use GeoGebra. It's not visual. What do? I looked at online calculators. That since 2020, I wasn't using Numbas. I looked at the similarities and the way that they solve each question. So what's the pattern? I looked at student submitted assessments, which are the popular ones for our students. Simple Lab is the most popular one. So I looked at how do they solve the question in Simple Lab. For Mathematics for Engineers 1, which is the first level 1 engineering mathematics unit, we asked them to solve questions, linear system of equations, using reduction methods or row operation, whichever way you define it, but we do not introduce row echelon form. They asked me during tutorials about, is this a row echelon form? You know that they are searching for online calculators. So this Simple Lab is the row echelon form, which must have, if you have any number in row 1, it must be 1. Most of the examples that we give to students starts with the number in row 1. Then zeros under the one in the first column. What I've done is, again, I'll have to minimize, but that's the last one, so it should be fine. Just take time sometimes. So I have written the question in a way that they have to use a different column. Remember, that was at the time that I checked the calculators in 2021. So I've introduced this. We do introduce how to solve row operations using not firmly column 1. So Simple Lab and other like common online calculators did not have the pivoting column or pivoting element. So they only use column 1. So I forced them here not to use column 1. You have to make the zeros here. We always show them in any row. I can ask them to have 2 zeros here and 1 0 there, 2 zeros here and 1 0 there. We ask them to have 3 zeros, 2 zeros in one row, 1 0 in one column, comma 0, like that's like a cross and like a plus intersection. So if you look at that, these A, B, C, D are guaranteed not to be zeros because of the way that I set up the question. And if you like at running the question, we'll change the numbers each time, as you can see in the linear system, but all of them, because you solve them in variables, guaranteed that they are not zero. So they are forced to use something else, not the online calculator at that time. But keep in mind that online calculators change. They get feedback from students and they give a lot for subscription. So we need to update always our knowledge, and it's not enough just to look at it once. You always need to check. All right, so these are some of the references that I used. I used only the first two, but I was aiming to show you the others, but I thought it's not going to be enough time. So thank you so much, everyone, for listening, and I hope you enjoyed it. If you have any questions, please.